Smiling faces in there. Go.
Welcome everybody to Senior Design Presentations on behalf of myself, my partner Eric, and everybody who's upstairs working right now. So today, for the first presentation, we're going to bring you a wireless conveyor belt system, which we'll get into more detail as we go along. So, our goals for this project were to control a relatively small, not industrial size, but small conveyor belt. And we're going to do it with an Android application that's not written in your standard Java programming language, because that's where Android apps are usually written. And the hope is that our final project is something that could eventually be developed upon and sold to consumers.
What is conveyor belt exactly? It's a continuous loop that's able to transport objects from one location to another, and it usually has more than two pulleys, or two or more pulleys that operate the chain to pull it through. The belt itself could be made of fabric, rubber, or metal. And usually one of the pulleys is powered to turn the belt through it. It transports goods efficiently and effectively between one place to another. Like, for instance, like you have a bottling factory, more than likely there's machines that do specific things, and to get from one machine to the other, we use conveyors to do that, instead of using humans to move the boxes around.
Note the difference between a conveyor belt that can do it uniform versus the man who's going to, take forever to carry that thing, especially if it's heavy and fragile.
Who uses them? The packaging, for instance, like I was talking about, they, for the most part, they take a packaged good, like to make that, they cook it and then they put it in packaging, and then that's transferred through several machines. Pharmaceutical companies use that to fill their pill bottles, and even the auto industry, they do that to facilitate the assembly of their cars. Typically, a conveyor is built with a frame that supports the whole structure, and then has two shafts that hold sprockets on either end. And then on top of the sprockets, there's a chain that wraps around through it. And one of the shafts is actually driven by a motor, which powers the conveyor belt forward.
So for controlling the belt, as I sort of mentioned before, we're using the Android application, and the Android application is going to have 6 buttons on it, which are going to turn it off, control its speed for 4 variable speeds, and set every one of those first 4 or 5 options is going to send a value to a text file saying, at this time of the day, on this day, the speed was changed to this setting. There's a 6th button that lets you clear that log in case you want to just have it for 1 day or for 1 month or 1 week, however long you choose to have it. And to do this application, as I said before, we're not using Java, we're using something called scripting language for Android. It's a packaging/API that allows you to write apps in languages other than Java. Some of the most common languages they use are Perl, Python, HTML, Rhino, JLua, Ruby, etc., etc. It's really useful for the scripting purposes, which Eclipse doesn't really give you. One of the great advantages of this, aside from the fact that you have other languages to choose from and operate on, is that there's a significant reduction in the source lines of code, which is how many lines of code you have in your application. Let's take a look at an example. Here on the left we have a basic Hello World program for all the engineers in the room. Hello World. That's a 20 lines, 30 lines, give or take. This is it in Python. 4 lines of code. Unfortunately, because S4LA is a proof of concept sort of application, it doesn't have all the functionality of every single language. Certain Python functions can't be called, certain HTML functions can't be called. Additionally, there's limited research and literature on the matter because the versions keep updating and old versions are not compatible with it, not backwards compatible, so you have to sort of look around and play around with things. There's an API browser, but it's not very good. So to use S4LA, you can either go to the Google Play Store, or you can look for it online and download it that way. And to run any sort of application with S4LA, any Python or HTML, you have to have S4LA or Py4LA or any of those programs on your computer. And you can upload them using the USB storage on your Android phone, or you can use Dropbox. I've sort of used both to upload programs at different times. And to run the app, you go go to the S4LA main page, and I'll show it in the demonstration, and you press the script and you run from console, which is the left option. There will be 5 options there. So we use the Android phone to connect to a Bluetooth module, which is going to receive the connection via serial interface agreement protocol, and it's going to take a UUID and a MAC address for the Bluetooth module and send that to the Android phone via a discovery feature. Now these two devices, the Android device and the Bluetooth module, they'll connect, and you'll be able to send information wirelessly through UART and at an established bits per second rate, which needs to be agreed upon. This data we're going to send to an Arduino board, if I didn't mention that before, and that's going to take the Bluetooth and control it. So the Arduino board is going to have an uploaded Arduino sketch, which is some sort of code written in that language, and it's going to have a Bluetooth module connection to talk to the Android phone. So I could have my Android phone right here connecting to the Arduino board, which I left upstairs with the Bluetooth module, with no computer attachments, just power. Nothing but power. There are also a bunch of pins that you can use on the Arduino to handle that data that's incoming and send signals or analog values or voltage values to say, do this or do this. Maybe control a motor, maybe control an LED, maybe control for us serial data.
Typically for an AC motor, there's 4 different options in order to change the speed. For our application, we want to change the speed of the motor. One of the options was pole changing. We can change like the poles of the motor, and each pole is able to turn the field through the induction motor, and that's able to change the speed of it. If you have more poles, then you slow the rotations per minute. That's costly, and that's something we didn't really want to do. Another way to do, you can change the line voltage, but when you change the line voltage, then you're creating too much power loss on your motor, so that's something that's not good either. Same thing with changing the rotor resistance. If you change the rotor resistance, then that'll generate, like, slow down your speed. So that's kind of costly too, because you lose your power through that. And so we want to go ahead with changing the frequency of the motor. By changing the frequency, there's virtually no loss of power through the motor. And we do that using a variable frequency drive. This drive particularly that we got takes a 120 VAC input and then outputs 120 VAC out. And we set up the drive in order to have 4 preset speeds, and we can do that using a 3-wire system. 1 wire is to turn it on and off, and the other 2 wires to adjust the speed. And we control those by using the relays. And by doing so, we would change the speed of the motor. By adjusting the frequency, you can make it go faster or slower by doing that.
So as you can see, this is the overall process that we've laid out. It's an Android phone, such as this one, connected to an Arduino microcontroller with a Bluetooth module attached to it, which will send signals via analog pins to a variable frequency drive, as Eric pointed out, which will relay that control to the motor that we will show for the conveyor belt. So, as I mentioned before with the S4LA, the conveyor belt script we wrote uses a Python main code for processing with an HTML layout to show for an application purpose to say, okay, this is what it looks like, these are your options. As you can see, all of this is built in HTML, this layout. Any of the buttons will send a signal to the Python script, which will do stuff, basically. So, as I was sort of mentioning, the HTML layout, as you saw, 5 buttons for different speeds, on, off, low, medium, high, and high, and then a final button for clearing. For each one of those first 5 options, you're going to send a speed and a timestamp to a file called, at the moment, called conveyor record schedule.txt. At that text file, it's going to show, at this time, you change the speed to this setting. The 6th button allows you to clear all the entries in the text so you can use it as many times you want for however long you want. Start a new log every day if you like. Choice is yours. The nice part about that text file I might also add is that you can edit it later. On the Android phone, you can send it via email to somewhere. You can upload it to your computer, whatever you really choose. For sending the data to Python, we use something called a droid object. And the droid object, which you create with Android applications in general, has a method called event post. That method is going to send a function call from HTML to Python. Python's going to know what to do with this later because it's waiting for that first call. This is the event post function 1, waits for that function on the other side. Then Python's going to do some stuff with the code, with the data, whatever it does, and send it back with an event post of function 2. HTML is going to receive that function 2 with this register callback function and process it as a result. So Python script for writing the text file that I was talking about, the Conveyor log, you have an append mode, which lets you add on different numerical lines to the text file, that each time you press a button, it's going to add a line. Then there's also the write mode, which allows you to clear the text file completely, start anew. The incoming data is also sent to the script for the little black box that you saw. It'll say, okay, the speed is this, off, or high, or medium low, or medium high, or any of those options. The Python to Bluetooth, we use Bluetooth Connect on the Droid, which is going to get the UUID and the MAC address, which is necessary to establish that connection. And once these two things are found, the script is going to connect, and it's going to read the line and read whatever line is sent to the Bluetooth and write to that Bluetooth. So there's the Python script on the phone, the Bluetooth module. This is going to be from the Bluetooth module reading lines of whatever's on the Arduino, and this is going to write to that Arduino whatever we choose to write. So our Bluetooth module is a 4-pin module. It's a tiny little thing, $8, relatively cheap, thank God. And you connect it 4 pins to the Arduino, 5 volt, a ground, an RX, which is a receiving pin, and a transmit pin on the board. Now, the Bluetooth actually connects to the Arduino with a serial connection. UART, RS-232, RFCOM, any number of protocols are at your disposal, I2C, SPI. And you send it at 9600 bits per second to make sure that you're getting all your bits clearly, concisely, no errors, none of that. The Arduino has a function for reading the board, reading the Bluetooth called serial.read, and that's going to read each incoming Python command. And then it's going to print a response signal to the phone saying, oh, off, oh, high, oh, low. The board, because it's uploading the sketch, it's already on the board when you put it into an outlet. It doesn't need the computer, and it's constantly looking for Bluetooth signals. As I sort of established already, the Arduino sketch writes these voltage levels of, based on the input, it's going to write out to an analog pin. That analog pin is going to go to the VFD later, but we're going to need we're going to need 3 pins on the Arduino to say, hey, this is this value that we want to send to the VFD. This is this value. And because it's a loop, we can do this as many times as we want. We don't have to stop the code and start all over. We can just say, okay, first off, then high, then low, and et cetera, et cetera.
And from the Android device to the drive, we have free relays that operate the turning on and off the drive. That'll be the first relay, and the other 2 relays are adjusting the speed. When relay 2 and 3 are closed, as you can see here, it's pretty simple. It changes what signals the drive is going to run the motor at. The low speed I picked as 1350. That's the lowest speed. It's a good operable speed that Conveyor can run, or Conveyor. And you can increase the speed higher as you change your outputs on your device. And the conveyor belt I actually built has a wooden frame and 2 sprockets, and you'll see in a moment just how it looks. And the motor itself is a single phase, and it's a 26-watt motor.
So we're just going to show you a sample of it actually working, what it looks like, how it looks on the phone. The video is not perfect, but it can work nice and clean. You want sound?
Okay.
Eric, do you want sound?
I don't think the sound works.
Yeah, Windows Media Player.
Oh, okay. Want to do one of those?
Yeah, we'll do it on Windows Media Player, sorry, Tom. Just so that you can actually hear the motor running faster and slower. It wasn't working for whatever reason. No big deal.
Hit the X key.
X key? It's no big deal, just run it.
Is there X in the corner?
How do you get this to the?
You have to drag it across.
Where's the button, Jason?
It should be in the top right corner.
Oh, this button. Where, top
And
right?
on that screen, there should be at the top right corner an X button to close out the presentation.
Okay. This
And
one?
then you'll be able to access the Windows Media Player at the bottom. And then you have to drag the player to the other side of the other
Oh,
screen.
we gotta stop it to start. Turn up the volume because I turned it down on the TV.
Yeah, that'll be fine.
Yeah, now press play.
Yeah, a little lower.
Oh,
Sorry for the technical difficulties, folks.
Go back to the beginning. That's the middle.
Alright, here we go. As you can see, we have the phone. That's our S4 LA at the opening. 5 options. Press the one on the left.